continuation of factorization for class 9th. In the previous two videos, we learned how to factorize a algebraic expression by three methods, and today's video we will be learning about the final method, that is the splitting of the middle term. Now for this, the algebraic expression has to be a trinomial of the form ax square plus bx plus c. A trinomial is an algebraic expression which has three terms and the powers of the variable are always whole numbers, meaning they cannot be fractions or they cannot be negative numbers. Now let us take some examples and try to understand this method. So you have exercise 4D, the first problem, x square plus 9x plus 18. Now as the name suggests, we have to split the middle term, that is 9x, and write it as the sum or difference of two numbers. Now those two numbers will be the factors of the product of 18 and the product of the coefficient of x square. Now since the coefficient of x square is 1, so it will be 18 into 1, which is 18 itself. So we have to find the factors of 18. Now note that there are two signs here. Now this number we have to split and write it as a sum or difference. How do we know whether we have to write it as a sum or difference? We look at these two signs. The second sign here tells us that we have to whether add or subtract the factors. Now since here the sign is positive, meaning the factors, you have to find the factors of 18, that's such that when you add them, I get 9. So the factors are 6 and 3. Now if you have difficulty to find the factors, then you can do the prime factorization. That is, you take prime factors 2, 9, 3 and by 3 and 3 as 1. Now from here you have to use the trial and the error method. So either you can take 3 into 3 is 9 into 2. Now 9 and 2 when you add, I do not get 9. What I get is 11. So the next one will be say 6 and 3. So 6 and 3 when you add, I get 9. Now when I have to add the factors, note that this sign goes to both the factors. So plus and plus. When you have to add the factors, the first sign goes to both the factors. So I have x square is equal to, so 9x I will write it as plus 6x plus 3x plus 18. So 9x I have written it as 6x plus 3x. From the next one, now since there are 4 terms, I will be taking a term common, a factor from the first two terms, that is x, and I have x plus 6. From the next two terms, I take 3 as a common factor and I get x plus 6. Note that the term, once you have taken a common factor, whatever is left in the bracket, that same is repeated when you take a common factor from the next two terms. So I am left with x plus 6 taking a common factor again, and this will be x plus 3. Therefore, these are the factors for this algebraic expression. Let us consider another example. Let us take the same problem. So I have x square, now here negative 9x plus 18. Now here again, you have to find the factors of 18 into 1, that is 18, such that when you add, I get 9, which is again 6 and 3c. Now here there is a negative sign. Since you are adding the factors, now this sign will go to both of them. So I have x square minus 6x minus 3x plus 18. Is this clear? The next step, I take a common factor from the first two terms, that is x, and x minus 6. And from the next I have 3 common, that is negative 3. So I have x minus 6 common. 3 minus 3 common, so I am left with x minus 6. So taking x minus 6 common, I am left with x minus 3, and that is these are the factors of this part. So note that when you have to add the factors and get the middle term, the first sign, whether if it is positive or if it is negative, goes to both the factors. Let us consider another problem. Problem number 2 from the exercise 4D. X square minus 5x minus 6. Now note here that there are two negative signs. Now so here I have to get 5x. So I have to split 5x such that For that I have to find the factors of 6. 6 into 1, that is 6. So find the factors of 6 such that when you subtract, I get 5. So which is 6 and 1 itself. Note that you cannot take 2 and 3 because if you subtract, I get negative or just 1. Now here, since you are subtracting the factors, note that now this first sign will go only to the highest factor, that is negative 6. And the opposite sign always goes to the lower factor. When you have to subtract the factors, the first sign only goes to the larger factor and the opposite sign goes to the smaller factor. So writing it down, I have x squared minus 6x plus x minus 6. 1 into x is x. So taking out a common factor, I have x minus 6, and here there is 1 common, so x minus 6. So taking x minus 6 as a common factor, I have x plus 1. That is it. Let us take another problem. Say the same one, I have x squared plus 5x minus 6. Again, what I have to do is find the factors of 6 such that when I subtract, I get 5. So it's going to be again 6 and 1. So here what happens is, now this sign, the first sign here is positive. So the positive sign will go to the greater one and the opposite sign goes to the smaller factor. So therefore I have x squared plus 6x minus 6. So taking out a common factor, I have x plus 6. From the next two, I take a negative 1 common. I am left with x plus 6. So that will be x plus 6 and x minus 1. So these are the 4 types. In the first 2 cases, we saw that when you have to add the factors, the first sign goes to both of them. In the next case, when you have to subtract the factors, the first sign goes to only the greater factor and the opposite sign goes to the lower factor. The trick here is to get the factors properly. So you can either do it by prime factorization method, or if you know directly, then also it is fine. Let's consider another problem number 9 from the same exercise. Now note that here there is a coefficient of x squared which is not 1. So how will I split this? Once I find the factor of 39 into 2. In the previous 4 examples there was 1, so it was the same number. So here 39 into 2 will give me 78. So it means I have to find the factors of 78 such that when you subtract them, I get 7. So since 78 is a greater number, let us find the factors by prime factorization method. So this is 2, 1, 3 and 13 into 1. So using trial and error method, you check which difference between two numbers, two factors of 78 will give you 7. Clearly it is 6 and 13. Okay. Since it is subtraction, the first sign goes only to the greater factor. So it is negative 13 and the opposite sign to the lower factor. So I write it as 2x squared minus 13x plus 6x minus 39. Now note that you could have written plus 6x first and negative 13x later, so that you could have maybe taken a common factor better. But even if you take it in this way, it's the same. Now from the first 2 terms, I take the common factor as x, so I am left with 2x minus 13. And from the next case, I have 3 as a common factor, so I am left with 2x minus 13. Note that these brackets are repeated. So I have x plus 3 and 2x minus 13. So therefore, these are the factors of this equation. Let us consider another problem. That is 7 plus 12 x minus 4x squared. Now the difference between this example and this one here is that the first term is a constant and the last term over here is the coefficient of x square or the x square term. Now here but note that the middle term is the same. The middle term is always in terms of x. So here again, irrespective of the switch between the first term and the last term, what we have to do is we have to find the factors of 4 into 7. Okay, so 4 into 7 is 28. So you have to find the factors of this such that when, now here irrespective of whether the terms are changed, the first sign here is to be given to only the greater factor. Why? Because you have to subtract those two factors to get 12. So that is nothing but 14 and 2. If you find difficulty to get it directly, use prime factorization method and then use trial and error method. So since it is subtraction, you have to subtract the factors. This sign will go to the greater one and the opposite sign to the smaller factor. So I have 7 plus 14x minus 2x minus 4x square. Taking out a common factor, I am left with 7 into 1 plus 2x negative. Now since here I need 1, so I will have to take entire 2x common. So that will be 1 plus 2x. So taking out again a common factor, I am left with 1 plus 2x and 7 minus 2x. So in this problem, irrespective of that first term and the last term exchange, note that the first sign here is given to the factors and the second sign explains whether you have to write as the sum or the difference of the factors here. Let us consider another problem. Now look at this problem carefully. It is a trinomial, but here there are two square terms. Do not make the mistake of using the difference of square terms or that a minus b or a plus b the whole square identity. Why? Because the coefficients of x here, at least in 1, is not the square of any number. And also you cannot take a common factor. Now in such types of problems, we have to use the splitting the middle term. Now in this case, you either take x as a constant or you take a as the constant. So in this case, I will be solving this problem taking a as the constant. So what will be is that I have x square minus 3a, I will consider this as one number, and 88a square I will also consider it as one number. So I have x square, then one x term and one constant. So now let us find the factors of the number part itself. So that was 2, 4 and 11. So the factors of 88 such that when you subtract I get 3 only is 11 and 8 from here. Now since it is subtraction, this sign goes to the greater one and the opposite sign to the smaller factor. So I will write it down as x square minus 11. Now since there is a and x, so that a I will write it and x as it is, and then plus 8ax minus 88a square as it is. Or to understand in a different way, instead of this I could have taken it as 8a, 11a and 8a. So which when you multiply I get 88a square. Anyway, whichever way you can understand. Now taking out a common factor, so it is x minus 11a plus 8a, x minus 11a. So taking out a common factor again, you get x minus 11a, x plus 8a. So in these types of problems, you consider either x or a as a constant. So if you had to consider x as a constant, then you would have got a problem wherein the last term is taken as the first term, but the signs would have remained the same. That is, this sign would have been given to the factors and this sign to subtract the factors. So since it is 88a square, so I find the factors of only the number, and the factors of a are a and a itself. So that is how it is. Substitute and you get it. Let us consider another example. Problem number 19. I have x square y square minus 12xy and 45. Now here, note that you have x square y square, that is the product of square terms. So I can write it as xy the whole square minus 12xy minus 45. So this is, if we consider this as one term, so you have it in the standard form, that is a trinomial form. So now you have to find the factors of 45 into 1, which is 45 itself, and the factors of this are 15 and 3. If it is still difficult, you can do prime factorization method and then use trial and error method to get the factors. Now since it is subtraction again, the sign here, the first sign goes to the greater one, opposite sign to the smaller one. So you are left with xy the whole square minus 15xy plus 3xy minus 45. Taking out xy as the common factor, I am left with xy minus 15 plus 3xy minus 15. So this is xy plus 3 and xy minus 15. That's it. Let's consider another problem. In place of a variable, we see that there is an entire bracket which is taking the place of x here. So what we'll have to do is we make a substitution. So say let x be equal to 3a plus b, since the same bracket has been repeated in place of x squared and x. So this algebraic expression will reduce as 5x squared plus 6x minus 8. So now you have to find the factors of 8 into 5, which is 40, and you have to find the factors such that when you subtract, I get 6, which is 10 and 4. So since it is subtraction, this sign will go to both of them, to the highest one, to the higher factor. So you have 5x squared plus 10x minus 4x minus 8. So taking 5x common, x plus 2 minus 4 common and x plus 2. So this is x plus 2 and I have 5x minus 4. Now don't leave it at this because your original expression was not given in terms of x. So now here you have to resubstitute. So resubstituting, I get, in place of x, I will put 3a plus b. It will be 3a plus b plus 2. And in the next case, 5, in place of x, I am putting 3a plus b minus 4. So that will be 3a plus b plus 2. And this will be 15a plus 5b minus 4. Let us consider another problem. Problem number 25. Note that you have just one bracket here and then there are 3 terms. From these 3 terms, you look at any 2 terms so that you can get the same bracket from the other 2 terms. So in this case, I have a plus 4 the whole square. Let us check if we get this common in any 2 of these terms. So that could be from here because there is 5 and there is 20, so I can get 1 and 4. So by taking negative 5b common, I get a plus 4 and minus 6b square. So since now we see that since there are 2 brackets which are one bracket which is repeated twice, we now make a substitution. Let a plus 4 equal to x. So this will be x square minus 5bx minus 6b square. This is the same type of problem which we have done earlier. You either take x as a constant or you take b as a constant. You can pause the video here and try to do this yourself. Let's consider problem number 27. We see here that there are 2 brackets which are repeating twice. That is 2a minus 3 and a minus 1. So here we'll have to make 2 substitutions. That is, let 2a minus 3 be equal to x and a minus 1 be equal to y. So you have the expression reduced as 4x square minus 3xy minus 7y square. So this again reduces to the previous type. So you have to find here the factors of 28 so that when you subtract you get 3. So which are the factors are 7 and 4 itself. So this will be subtraction, this will be addition. So I have 4x square minus 7xy plus 4xy minus 7y square. I am taking y, the y terms or the y variable as the constant. So taking a common factor, here the common factor is x. So this will be 4x minus 7y and here the common factor is plus y. That is 4x minus 7y. That is x plus y and 4x minus 7y. Do not forget to resubstitute. So resubstituting, I get this as x plus y is 2a minus 3 plus a minus 1 And for the next one, 4 into x, that is 2a minus 3 and minus 7 times y, a minus 1. So this will be 3a minus 4, and this is 8a minus 7a, which is a, and then you have minus 12 plus 7, minus 12 plus 7, which will be negative 5. That is the answer. Problem number 29. This is another type. We have to first write it as a trinomial form. So here we have outside the bracket. Now so there are two brackets which are multiplied, and we see this is the smaller one, that is a square minus a. So we see if this same thing can be obtained from any of these three terms. Okay, so this will be a square minus a. Now from here, look at these two terms. From this, if I take a 4 common, then I get this same term. So that will be taking 4 common. I have a square minus a minus 5 minus 6. So now here make a substitution. Let a square minus a be equal to x. So this will be x into 4x minus 5 minus 6. What will be the next step? You open up the bracket. So I have 4x square minus 5x minus 6. Now this is a trinomial. So how do you factorize this? You have to find the factors of 6 into 4. That is 24, such that when you subtract, I have to get 5. So this will be, so use prime factorization method, otherwise you have 2, 1, 2, 2, 6 and 3 and 1. So this could be 8 and 3. Okay. So now since it is subtraction, this sign goes to this the greater one, opposite sign to the smaller one. So I am left with 4x square minus 8x plus 3x minus 6. This is 4x, x minus 2 plus 3, x minus 2. And this is 4x plus 3 and x minus 2. Do not forget to resubstitute. So resubstituting, I get it as 4 in substituting x. I have a square minus a plus 3, and this will be a square minus a minus 2. So this is 4a square minus 4a plus 3, and this will be a square minus a minus 2. Now note that this is again products of two trinomials. You check if you can find the factors here. You have 4 into 3, which is 12. Can you find the factors of 12, which when you subtract I'll get 4? Yes. Which when I add I'll get 4? No. If you have to subtract, then I would have taken it as 6 and 2. But since it is addition, I cannot find the factors for this one. Let us check for the next one. The factors of 2, which when you subtract I get 1, are 2 and 1. So this I will factorize further. So 4a square minus 4a plus 3. This will be a square minus 2a plus a minus 2. So which will be 4a square minus 4a plus 3, and this will be a common. So I have a minus 2 plus a minus 2. Therefore 4a square minus 4a plus 3. This is a minus 2 and a plus 1. Once you get it as a product of two trinomials, check if you can find its factors. If it is a greater number and you have to add to get a smaller number, it is almost impossible. It will not be possible. But in such a case, if you have a greater number which you have to reduce to get a smaller number, check if you can find the factors and factorize it further. So this will be the factors of this given algebraic expression or the trinomial. Note that we have here a raised to 4 minus 11a square plus 10. Now note that this is a trinomial wherein here the power of x, in this case the highest one is 4. Now note that since 4 is a multiple of 2, I can write it down as a square the whole square minus 11a square plus 10. So I'll make a substitution for a square. If you can continue without it also, very good. So I have x square minus 11x plus 10. Now the factors of 10 are such that when you add you get 11 are 10 and 1. Since you had to add, this sign goes to both of them. So this is x square minus 10x minus x plus 10. Therefore you get x common, so x minus 10. And from here negative 1 common, so I get x minus 10. And that will be x minus 10 and x minus 1. If you have put a substitution, do not forget to resubstitute it. So I have resubstituting, I get a square minus 10 and I have a square minus 1. Now note that this is the difference of square identity. Now over here 10, there is a 10 and there is 1 here. Since 10 is a since 1 can be written as a square of a natural number, so we will be only expanding this, and this you leave it as it is. So this will be a square minus 10, this will be a plus 1 and a minus 1. We are leaving this as it is because 10 cannot be written as a square of an whole number. Today we have learned how to solve how to factorize an algebraic expression by the method of splitting the middle term. So based on the examples that we have solved today, try to solve the remaining problems from exercise 40. Thank you.